Look up at the night sky. For many, Saturn comes to mind first. Its glorious rings make it the jewel of our solar system. But what if I told you those iconic rings are vanishing? Saturn is losing its rings, and it's happening faster than we thought. Scientists call this ring rain. Tiny ice and dust particles are pulled in by Saturn's gravity, bombarded by micrometeoroids and solar radiation, then funneled into the planet's atmosphere. This cosmic erosion is quietly dismantling one of the most beautiful sights in our solar system. How long do the rings have left? Some models predict they could disappear in as little as 100 million years, a blink in cosmic time. Our solar system is over 4.5 billion years old, so we're lucky to witness Saturn's rings at their peak. This discovery reframes our perspective. What we see today is just a fleeting moment. Planets evolve, their features come and go. We are privileged witnesses to a temporary masterpiece. It's a humbling realization. The universe doesn't wait for us. We have to be curious, to look up and to explore these wonders while we still can. Saturn's rings remind us, even the grandest cosmic features are not forever. The universe is always changing. Our time to observe these wonders is precious. So let's keep asking questions. Let's keep exploring. Because these cosmic marvels might not be there forever. For decades, telescopes like Hubble and probes like Voyager have shown us the universe's wonders. Now, we have a new, more powerful eye, the James Webb Space Telescope, or JWST. Webb is a revolutionary instrument, seeing the universe in infrared, light invisible to our eyes. Infrared lets us peer through cosmic dust, revealing the birthplaces of stars and planets, and analyzing distant worlds' atmospheres. For the outer planets, Jupiter, Saturn, Uranus, Neptune, this is a game-changer. Webb's infrared vision cuts through hazy atmospheres, revealing details we've never seen before: temperature variations, chemical signatures, and weather patterns. Its engineering is a marvel. A 6.5-meter gold-coated mirror and a sunshield the size of a tennis court keep it cold enough to detect faint infrared light. With Webb, we're not just looking at planets, we're dissecting them, exploring their systems in breathtaking detail. Webb isn't just taking prettier pictures, it's delivering a flood of new data, challenging old theories and sparking new questions. The era of the James Webb Space Telescope is a new dawn for planetary science. It's a new chapter in our quest to understand our place in the universe. And it all starts right here, in our own cosmic backyard. With Webb, we're seeing the solar system as never before. The mysteries of the outer planets are finally within reach, the universe is opening up, and we're just getting started. When Webb turned its golden eye to Saturn, the images were astonishing. In infrared, Saturn's planet appears dark. Methane in its atmosphere absorbs sunlight, while the rings blaze with ethereal glow. Webb reveals hidden structures in the rings, including faint dusty rings and intricate patterns shaped by Saturn's moons. It's like discovering a new map of a familiar place, full of hidden details. Webb's clarity also brings Saturn's moons, Dione, Tethys, and especially Enceladus, into sharp focus. These aren't just dots. Webb can analyze their heat signatures and even the material spewing from Enceladus's geysers. By studying these plumes, Webb searches for the building blocks of life. Webb also uncovers Saturn's atmospheric secrets, bright polar features, subtle cloud bands, and signs of powerful storms. We're moving beyond the surface, starting to understand the deep, complex engine driving this gas giant. Webb is peeling back Saturn's layers, one infrared image at a time. The mysteries of Saturn are coming into focus. Saturn isn't the only giant transformed by Webb. Webb's tour of the outer planets has delivered stunning surprises. Jupiter's Great Red Spot and countless storms are revealed in unprecedented detail, along with its faint, dusty rings and polar auroras. Even tiny moons orbiting within Jupiter's rings are visible. Uranus, once a bland blue ball, now shows faint rings, a bright polar cap, and active storms. Neptune's rings are clearer than ever, and its atmosphere glows with high-altitude methane ice clouds tracing powerful winds. Webb has even captured all 7 of Neptune's inner moons. From Jupiter's raging storms to Neptune's icy clouds, Webb is painting a vibrant new portrait of our solar system's giants. Each planet is more dynamic and complex than we ever imagined. Webb is rewriting what we know about the outer solar system. The family portrait of our cosmic neighborhood has never looked so alive, and there's still so much more to discover. Among Saturn's moons, Enceladus stands out, a tiny world with a giant secret. Beneath its icy crust lies a global ocean of liquid water, revealed by plumes erupting from its south pole. These plumes, analyzed by Webb, contain water, methane, carbon dioxide, ammonia, and complex organic molecules, the ingredients for life. Enceladus is too far from the sun for warmth. Instead, Saturn's gravity generates heat through tidal forces, keeping its ocean liquid. At the ocean's bottom, hydrothermal vents may exist, just like those on Earth where life thrives in darkness. Could something similar be happening on Enceladus? We have water, energy, and organic molecules, all the conditions for life. Webb's observations bring us closer to answering one of humanity's biggest questions: are we alone? Enceladus is one of our best hopes for finding life beyond Earth, a hidden ocean, a cosmic oasis in the cold darkness of the outer solar system. The search is just beginning, the evidence is tantalizing, and the implications are profound. Science isn't about having all the answers, it's about asking the right questions. The James Webb Space Telescope's discoveries are a perfect example. Its images of Saturn's rings, Jupiter's storms, and the dynamic atmospheres of Uranus and Neptune are more than just pretty pictures, they're data. This data is forcing us to rethink how planets form and evolve. The outer solar system is far more dynamic than we once believed. Saturn's rings, once thought eternal, are now known to be fleeting. This challenges our assumptions and sparks new questions. How did the rings form? What does their youth tell us about Saturn's history? Critical thinking is the engine of science, questioning, debating, and testing new ideas. Science is self-correcting. It's about being willing to change your mind in the face of new evidence. Webb's discoveries are pushing planetary scientists to think deeper and build better models. The process can be uncomfortable, but it's where breakthroughs happen. The universe is full of surprises, and science is how we uncover them. The story of Saturn's disappearing rings and Webb's revelations is more than science. It's an invitation. It's a call to curiosity, to explore the universe's grandest mysteries. We need more than curiosity, we need critical thinking to turn wonder into understanding. Teaching the next generation how to analyze evidence and ask good questions is essential. New tools, like interactive lessons and digital models, can make science accessible and exciting for everyone. The universe is the ultimate laboratory, and its mysteries are waiting to be solved. Saturn's fading rings remind us our window to observe cosmic wonders is precious. Webb has opened that window wider than ever. Now it's up to us, and the next generation, to keep exploring. The cosmos is calling, and we must answer.